Hello friends, today we will discuss how we can convert digital signals to analog signals or analog signals to the digital signal. There are certain quantities like temperature, pressure, current, voltage, etc. These are the physical quantities and they are continuous in nature because all the value exists. Okay, so they are called continuous. हम इनको continuous बोलते हैं because voltage, current, temperature को continuous इनकी values exist करती हैं और जिनकी value continuous हो उनको बोला जाता है analog signal. Okay, so it is more convenient to convert first of all to have the signal in digital form, not in analog form. Microprocessor also handles only the digital signals, not the analog. Okay, क्या आपको पता है कि माइक्रोप्रोसेसर भी डिजिटल सिग्नल को समझता है, एनालॉग को नहीं समझता. ठीक है, तो हमें डाटा डिजिट्स में ही चाहिए, नॉट एनालॉग फॉर्म में. So to process a physical quantities, first of all we'll convert that analog signal to digital. Then we will process it with the help of microprocessor, etc. Then after that again we will convert that digital data to the analog signal. Okay, तो हमें पहले क्या करेंगे कि फिजिकल क्वांटिटी जो होगी एनालॉग सिग्नल होगा उसको डिजिट्स में चेंज करेंगे, तो फिर हमारा माइक्रो प्रोसेसर वगैरह उसे प्रोसेस करेगा, उसके बाद फिर हम उसको एनालॉग सिग्नल बना सकते हैं. तो हमें दो कन्वर्शन चाहिए, पहला एनालॉग से डिजिटल में जाने के लिए, फिर डिजिटल से एनालॉग में आने के लिए. ओके, so let me understand how we can convert digital signal to analog signal. Okay, तो हमें समझना है अब कि हम डिजिटल सिग्नल को एनालॉग कैसे बना सकते हैं. तो ये जो आपको दिखाई दे रहा है बॉक्स, ये सपोज DAC है. ओके, ये कन्वर्टर है. हम इसको बिट्स दे रहे हैं B1, B2 एंड BN, और ये हमें क्या दे रहा है, ये हमें उसको एनालॉग सिग्नल बना के देगा आउटपुट में. तो एक बात ध्यान रखनी है कि यहाँ पे जो B1 है ये मोस्ट सिग्निफिकेंट बिट है और BN लीस्ट सिग्निफिकेंट बिट है. सो हियर like there is a box which is DAC and we are giving bits. Okay, we are giving input in the form of bits, and DAC will give us the analog output. Vout mean analog output. Okay, the various types of ADC, the types, various types of ADC, it depends upon number of bits used as the input, like how many bits we are using as the input. Like if we are using 8 bit as input to convert it into the analog, 16-bit input, 32-bit input, like that. So the types depends upon how many bits, okay, which are converted into the analog signal. तो इसकी जो कन्वर्शन है ये डिपेंड करेगी कि हम कितनी सारी बिट्स को कन्वर्ट करने जा रहे हैं. आउटपुट डिपेंड करेगी कि हम टाइप्स डिपेंड करेंगे कि हम 8 बिट को कन्वर्ट करना, इसको बनाना चाहते हैं एनालॉग सिग्नल, 16 बिट को एनालॉग में ले जाना चाहते हैं, 32 बिट्स इनपुट को एनालॉग सिग्नल में ले जाना चाहते हैं. इस पे डिपेंड करता है कि वो एडीसी किस टाइप का है, एनालॉग से डिजिटल कन्वर्टर किस टाइप का है. Let me consider an example that we are having 4-bit input TA converter with full scale output voltage is 150 volt. That we can use this much voltage at the output. Okay, 4-bit, the various combinations are like there's a least significant bit 0101, then next one 0011, then 4041, then 8081. So these are the various combinations of the bits. Okay, you will find the total, total combination 16. First one is 000, then 15 others. So they are the total 16. First one is 0. So the combination into the decimal numbers. So 0 to 15. Okay, 0 to 15. So there are 15 levels. If we exclude the zeros, then if you include 0, then 16 for 4-bit DA converter, So this one is the, this least significant bit is B4 and most significant bit is B1. B1 is most significant bit. Okay. The next is, because, input we're having 15 levels, 15 combinations. If we are not including 0, then if we include 0, then it becomes 16. 16, that means 2 raised to power 4 is 16. 15 level excluding 0. 16 levels including 0. And because, the output is 150 volt and we divide 150 volt into the amongst the various levels. Like 150 over 2 raised to power n minus 1, 2 raised to power n minus 1, 2 raised to power n. Mean like our example 2 raised to power 4 means 16 minus 1, 15. 150 over 15 becomes 10 volts. Mean you can give 10 volts to each level. Okay, मतलब कि 10 वोल्ट मिल सकता है हर एक का बिट्स के पैटर्न को. Okay. So along x-axis we will have 16 points including 0, and along y-axis again 16 points. Now along x-axis, because it's a independent quantity, it is our input are the bits, and we are having total bits pattern, they are total 16. So this is the least significant bit, 010101, 2 zeros 21, 2 zeros 21, next one, 4 zeros for 1, 4 zeros for 1, next one, 8081s, 8081s, next one. That's the most significant bit. So this is B4, B3, B1, B2, B3, B4. B4 is the least, B1 is the most. Now divide 150 into the 15 levels, 10, 20, 30, 40, up to 150. So this is, like we are giving the voltage to each pattern. To each bit pattern we are giving voltage, like 60 volt to this, 70 volt to this pattern, 80 volt to this pattern, 90 volt to this 1001, then 100 volt to this, then this one, okay, 130 to this 11101, 10, 150 to all ones. So joining all the points, we will have a straight line exactly. Along the second y-axis, we are having the decimal values of the bit patterns. So these are the decimal values, 1, 2, like that, so on, up to 15. So this graph will tell us that for each bit pattern, how much voltage we will have at the output side. Okay, at the output, how much voltage will be there for each bit pattern. So along x-axis digital input, along y-axis is the, analog output. Okay, how much output voltage for each bit pattern, right? The performance parameter of the digital to analog converter is, first of all, it is the resolution. What the mean of the resolution? Because this converter will convert bits to the analog signal, bits to the voltage. So we'll have, like if I using 4 bits and 4 bits having different 16 pattern including 0. So we can, so if we exclude 0, then there are 15 pattern, and then the output voltage will be divided into and amongst all the 15 pattern. So that becomes the resolution. Resolution means number of different analog output values, and or in turns it depends upon number of the input bits. Like resolution 2 raised to power n. If n is 4, that means 16. If n is 4, that means 16. That means 16 different levels or 16 different bits pattern, because 4 is number of bits and different combination becomes 16. So 16 is called the resolution. And then we'll have the, including 0, 16 output voltage level. That becomes the resolution. Here I am having the, like now the second one is how much the voltage change if we just shifts to 1 bit along the right hand side, along the x-axis. So if we shift 1 bit along the x-axis, then how much the voltage will change? That will change 10 volt. The resolution becomes, like 10 volt per 10, the 150 is called full scale of output voltage. Total output voltage which is used and divided by 2 raised to power n minus 1. That 16 minus 1, 15. That 150 over 15, that becomes the, 10 volts in above example. The other example is if we are having 10.2 volts as a full scale voltage, and we are using 8 bits, 2 raised to power n, 2 raised to power 8 minus 1. So it becomes 60 millivolts per bit shift. If we shift with 1 bit, along the x-axis, then the voltage at the output will change 40 millivolt. 40 millivolt will change, the voltage will change at the output with the change of 1 bit along the x-axis. Okay. Now the second parameter is the conversion time. Okay, how much the time the converter takes for conversion from digital signal to the analog signal, how much time it takes. Okay, conversion time is some time required for conversion from analog signal to the digital signal. Okay, that's called the conversion time. And in turn, the conversion time depends upon, the speed of the switches used. So it is also called the, sitting time. Okay. The third parameter is stability, and it is very clear, that the semiconductor are sensitive to temperature. Temperature always affects their performance. So, as well as, the performance also depends upon the age and the power supply variation. So, all these parameters relates to the stability. All these variations, okay, all the effects relates to the stability. Now we are going to discuss the first technique for conversion digital to the analog signal. Here we are having some voltage, then a resistor. Okay, then this line, the second resistor, then switch, third resistor, then a switch, fourth resistor, then a switch. This is an example of the 4 bits. Then the switches. So this particular diagram for the 4 bits. Switches name S1, S2, S3 up to Sn. Sn, the least significant bit. Resistors 2R, 4R, 8R, 2 raised to power NR. Then we're having op, negative terminal. Then the feedback resistor, RF. Then plus terminal grounded. Okay. Now, the switch can be open or closed with the bits. If the bit is present, if it is 1, the switch is closed. If the bit is 0, it is open. So, Bn is the least significant bit and B1 is the most significant. The whole current will pass through RF because op never throws any current. The current I1, I2, I3 up to In. The total current is IT, which is the sum of all the currents. So I is basically equals to I1 is equals to V upon 2R, and then I2 will be equals to voltage is the same along the parallel path, then V upon 4R, I3 V upon 8R and up to IN V upon 2 raised to power N into R by Ohm's law. Okay. So I is the sum of I1 plus I2 up to IN. IT is total current, okay, which is passing through RF. And current is there if the bit is present, like B1. If B1 is present at 1, then there is current I1. Otherwise, if B1 is 0, then there will be no current. The bit may be 1 or 0, depending upon that, the total current. And output voltage is minus because negative terminal we're using of the op is inverting op amplifier. So the output voltage is minus IT into RF, substituting the value of IT here. Okay, and then substituting the various currents in the formula. We are substituting I1, I2, I3, all that. Remember, the current depends upon the presence of the bit. If bit is 1, then that contributes to current. So then, some parameter V upon R taken as common. And it is written like this. Then, here it is writing like in this way, simple mathematics. Now if RF and R they are equal, the output voltage modifies too. The one thing remember, the output result shows that the output voltage, the result shows that output voltage is proportional to the V, which is the input, which is voltage V as well. So it is very clear that if the V is constant, that input voltage is constant, then the output voltage will depend only upon the bit patterns, mean the values of bit. Okay, B1, B2, B3 and so on up to Bn. That means this is the technique that we convert the bit patterns into the output voltage, proportional output voltage accordingly. The bits pattern, or we can say. And now what's the drawback? Now the wide range of resistors values are required here, like 2R, 4R, 8R and 2 raised to power NR. For 8-bit tag, the resistor values 2R, 4R, 8R and up to so on. And how many resistors are required? Just calculate. So that's a very, and the largest resistor is, again note down, 128 times the smallest one. So a wide range of resistors are required. That's the limitation of this tag. Thank you very much. Please subscribe my channel. Okay.